Welcome to Lesson 4, when we'll be looking at the new features in 19C for DataGuard and the DataGuard broker. So after completing this lesson, you should be able to configure automatic redirection of DML operations, explain the functionality of replicated restore points, and demonstrate how to dynamically change the fast start failover targets. So first of all, let's look at replicated restore points. Restore points been around since I think 10G or 2, I think they were introduced. They are like bookmarks for a particular point in time, and they're stored inside the database's control file. Now, because they're stored in the control file, up until 19C, they were unique to a database. So if you created a restore point inside the primary database, that did not appear inside any of your standby databases. That's not true anymore. Restore points that you create on the primary database will be automatically replicated to your standby database. These restore points created on the standby database are called replicated restore points. If you look inside $restore point view, you'll find there's a new column there saying whether they have been replicated or not. Oracle Database automatically replicates restore points from a primary database to the standby database when the following conditions are met. So the compatible initialization parameter for both the primary database and the standby database must be 19 or higher, and the primary database must be open. Because the restore points are replicated using redo, the database doesn't create redo if it's mounted. So if you create a restore point with the database mounted, this cannot be replicated across to your standby database. So these replicated restore points only created if the primary database is open. The naming convention for a replicated restore point uses the name of the restore point in the primary and suffixes it with underscore primary. So if you were to create the restore point in the primary as pre-upgrade, then in the standby it would be called pre-upgrade underscore primary. The managed redo process, MRP, manages the creation and maintenance of these replicated restore points. To determine if a restore point is automatically replicated, you can query the $restore point view in the standby database to see if it has actually been replicated from the primary. Now, one of these things that these replicated restore points can make easier for us is flashback in the standby. So if you flashback your primary database, you can flashback the standby database to the same restore point, but you don't need to, because we now have automatic flashback of the standby after the primary database has. So the standby database that is in the mounted state can automatically follow the primary database after the reset logs operation on the primary. So you have flashbacked a primary database, you are happy with the fact of the point in time that that primary database is now at, so you now open up the primary database using the reset logs operation. That will now, if you like, trigger that your standby databases will also be flashed back to the same point in time and will also be opened up. When the flashback, or sorry, not opened up, it returned to its original state, I should say. When the flashback or point in time recovery is performed either on the primary database or inside a PDB inside the primary database, the primary database or the PDB will be moved to the previous point in time. The primary is then opened with the reset logs option, and the new incarnation of the primary or the PDB inside the primary is created. For the standbys to automatically follow the primary, the MRP detects the new incarnation has happened because of the reset logs. It flashes back the standby or the PDB on the standby to the same point in time as that of the primary or the PDB on the primary, and restarts the standby recovery and moves the standby to the new branch of redo. Now, if this will only happen if your standby is mounted. So if your standby is open read only, then this flashback will not take place. There will be messages in the alert log saying that it should have happened, that we couldn't because the database was open. When you close the database, if you close the standby database, that is when MRP will actually perform the flashback. If you do not want that standby database to be flashed back, then shut down the managed recovery process, end the recovery, or keep the standby database open. Now, in-memory column store introduced in 12.1, and the multi-instance redo apply, which was introduced in 12CR2. Now, up until 19C, you could not have both of these switched on at the same time in an active data guard environment. Well, we've now fixed that. So Oracle Database in-memory column store and the data guard multi-instance redo apply can be configured at the same time in an active data guard standby database. Well, why an active data guard standby database? Well, this is open read-only and redo is being applied. So this is, well, if it's open read-only and redo being applied, well, it needs to be open read-only to, well, it needs to be open to allow you to use the in-memory column store. And if redo is being applied, then you probably do want to make use of the multi-instance redo apply to make your apply process more efficient. If you've missed what multi-instance redo apply is, well, traditionally, well, prior to 12CR2, if your standby environment was a rack standby environment, you could actually only apply the redo being generated from your primary database on one instance. From 12CR2, you can actually run it on multi-instances, which will make it more, the performance of the redo apply better. So to use in-memory column store with multi-instance redo apply in the active data guard environment, there is this new initialization parameter, enable in-memory column store with multi-instance redo apply, and you need to set that to true. The clause is only applicable for real application cluster databases or Rack 1 node databases. These are the only ones where you can do multi-instance redo apply in. And you cannot use multi-instance redo apply with the standby no logging for data availability or standby no logging for low performance functionality, which was, if this has been enabled on the primary, then you can't use multi-instance redo apply. If you're not familiar with these two, these are new functionalities support no logging operations, which were introduced in 18C. We're looking at some new functionality for the active data guard standby databases again. Remember, these are standby databases which are open, read only, but redo is still being applied. The benefits of this is that you can run real-time reporting or near real-time reporting on these standby databases. So you can run reports and the data can be updated at the same time. Now, DML operations can now also run on these active data guard standby databases. Now, if you are using these databases reporting, sometimes your reporting can be very complex and needs the creation of temporary tables, something that we have allowed you to do in previous releases of Active Data Guard, or previous releases of the database. Sometimes that reporting also requires you to do some minor updates of the data in the database as well. Now, because the database is read-only, you can't do that. But you can now, because these DML operations that perform on the standby database will actually be redirected to the primary, be performed on the primary, and then be seen inside the standby environment. So this enables you to run read-mostly applications, which occasionally have to execute some DML. They're executed on the standby database, but the data changes actually take place on the primary and then filter through. DML operations on standby can be transparently redirected to and run on the primary database. The Active Data Guard session waits until the corresponding changes are shipped and applied to the Active Data Guard standby. Read consistency is maintained during the DML operations, and the standby database on which the DML is run can view its uncommitted changes. So until you commit that data, the only person which can see the data that's been changed is the person who's issued that command. So inside their session, that data has been changed. Everywhere else, it hasn't been. All the other standby database instances can view these changes only after the transaction has been committed. When you commit your transaction, it's redirected to be committed on the primary and then will be filtered down into all your standby databases. Same information really in a more pictorial form. So your client here has issued some DML on your active standby. The DML has been redirected to the primary. The DML is applied to the primary. The data change is streamed back to the standby database where the data is now visible to the client. When the client commits that, then the commit is applied on the primary and is streamed back not only to the standby database but to any other standby databases you have as well. This enables you to run read-mostly applications which occasionally execute DMLs on the standby database. So how do we configure this? Well, we can configure it at either the system level or the session level. So automatic redirection of DML operations, the primary, can be configured at, as I say, system or session. If you want to do it at the system level, this means it will apply to all standby sessions. And to do this, we have a new initialization parameter called ADG redirect DML. So active data guard redirect DML. That's set to true. Then all sessions will have DML operations redirected to the primary and then applied to the standby. If you only want to do it one session at a time or for one and one off session, then it can be set at the session level as well. So alter session enable ADG redirect DML. The session level setting will override the system level setting. So if you set this to true, but you set this to disable, then this particular session won't be allowed to do it. You can also, if you're in a rack environment, you can have this set differently on different instances. So some instances could have it enabled and other instances may not. So here we have an example. You've got a physical standby database and an active data guard set up, and it contains a table called employees. To insert rows into this table by running DML on the physical standby database, in your session we have alter session enable ADG redirect DML. We then insert a row into the employees table, and the new data will be visible only to the standby database on which the command was run until it's been committed. Once it's been committed, where after the insert is committed on the primary database, the changes are shipped back and applied to all the standby databases. Now, in very similar fashion, you can also run PL SQL operations on an active data guard standby database. And these PL SQL operations will be redirected to the primary and therefore eventually filter through to your standby. So PL SQL blocks that you run on an active data guard standby database can be redirected to and run on the primary database. They can't contain any bind variables though. To redirect PL SQL operations that are run on the standby to the primary, this is a session level functionality, so it's alter session enable ADG redirect PL SQL. It can only be done at the session level. It's not a system initialization parameter. Just a few mentions of some DataGuard supported features. The max connection attribute for the log archive destination initialization parameters is now desupported. We also have desupported the extended data support, EDS support. All EDS supported Oracle data types are now supported natively by either Logical Standby or Oracle Golden Gate, so there's no need for us to actually still offer support for these extended data type supports. And that's the end of part 1 of this lesson. Welcome to part 2 of 19C new features for DataGuard and the DataGuard broker. And in part 2 we'll be looking specifically at the broker, what changes are there for the broker. First we're going to look at is changes to the way that you can change the target for a fast start failover. Now currently you can have a list of targets The broker will have the first standby database on that list as its failover target. But if that failover target, something happens to it, it goes offline for some reason, it will actually fail over its failover target, if you like, to the next database on the list. If you wanted to put it back to the first database on the list, this would actually require you to disable the fast start failover and maybe modify the fast start failover list as well. But not in 19C. In 19C, we can actually set the fast start failover target without having to disable the fast start failover or modifying the fast start failover list. The database you want to reset, well, the database that you want to point the fast start failover at has to already be on this list though. You can't just invent a new database, if you like, or not invent, install a new database. It must already be on the list. So the syntax for the set fast start failover target is as follows inside the broker: set fast start failover target to, and then whatever your database name is. You have the option to say no wait, which means do it immediately now, or otherwise there could be some delay. The following example shows how to set the fast start failover target to the standby database called Boston. So set fast start failover target to Boston, and it says changing the fast start failover target to Boston. And then eventually it will come and say succeeded. If you want it to take place immediately, as we say, we can use a no wait clause. So fast start failover at the moment shows us our target is Nashua. With the potential targets, well, you've got this is the first target. If Nashua is not available for some reason, we're going to use Boston instead. But we can now say set fast start failover target to Boston, no wait. It says it has received the request. The request has been received. And if we show fast start failover now, we can see the active is Boston there. Another new feature for fast start failover is you can now run in observe only mode. Now, if you're using fast start failover, you have an observer which is monitoring conditions to do with your primary database. If all of those conditions or some of those conditions are met, it will automatically fail over to your standby database. Now, this can make people, I've met people say, oh no, we don't want that because we're unsure of when it will do it and how it will do it. If you're not sure whether this is for you, you can now run in this observe only mode, and it will, rather than fail over to your standby database, it will record that we would have failed over to your standby database now. This also allows you, if you want to change parameters, which circumstances do you fail over under, you can actually work on these parameters, change them until you are happy that you are going to fail over only in circumstances that you really want to fail over in. So the observe only mode for fast start failover enables you to test how the fast start failover will work in your environment. The observe only mode has no impact on your current configurations or on the applications. In this mode, no actual changes are made to your broker configurations. When the conditions that you specify for fast start failover have been met, the broker will add messages to the observer log and the broker log indicating that the fast start failover would have been initiated but weren't because you're in observe only mode. If you want to configure fast start failover in observe only mode, well, this is a dgmgrl command, enable fast start failover and specify observe only. Leaving fast start failover behind, let's look at some broker configuration commands. You can now export your broker configuration into a text file. So the export configuration command enables you to save the metadata contained in the broker configuration into a text file. This command to maintain an up-to-date copy of the broker configuration metadata, or use this command to maintain this up-to-date copy. The command format is export configuration to an optional file name. Now you can specify the file name, you can't specify which directory it's going to go into though. It will always go into the trace directory for your database. If you don't specify a file name, it will generate an automatic file naming convention for you. So here we are doing an export configuration to the dgconfig.txt file in the trace directory. Now, where would you use this? Well, let's say you are for some reason having to downgrade your software level and you want to preserve the broker configuration you had. You can export the broker configuration to a text file, and then once the downgrade is finished, you can then import the broker configuration. So the import configuration command allows you to import the broker configuration metadata that was previously exported using the export configuration command. Command format is import configuration from the file name. You don't need to specify the directory because it will always be imported from the trace directory. The imported metadata is then stored in the in-memory metadata and either of the metadata files specified by the DG broker config file 1 or the DG broker config file 2 parameters. So here is an example of the full command import configuration from ddconfig.txt. The broker now has new commands to set, modify and display initialization parameters. Now, in the past, you changed initialization parameters by using edit database set property command, and the property you were setting were related to instance parameters or initialization parameters, and the properties were stored inside the broker configuration, or metadata I should say, and also translated into alter system commands to be executed on your databases. This all seems a bit complex, so we now have commands to directly edit initialization parameters, or I should say set, modify and display the values of database initialization parameters. These will no longer be stored as properties inside the broker metadata. I'm going to show you some examples of these commands in the next few pages, but let's look at the samples of the syntax first. We've got edit database parameter. So you're editing a parameter, initialization parameter. You can reset initialization parameter back to its default setting. This is for your primary and standby databases, but you can also specify them for your fast sync instances and also for your recovery appliances as well. So here we are resetting a parameter in fast sync. We are setting a parameter on the recovery appliance, and we're resetting on the recovery appliance as well. This is a new command for the broker, but it's nothing to do with setting parameters inside the database. We can actually set the trace level for the broker, the client side of the broker itself. So let's look at some examples of these new edit database commands. So edit database set parameter command sets the specified initialization parameter for the named database. So the following example edits the initialization parameter called log archive trace for the database named North Sales and sets it to the value of 1. So edit database North Sales set parameter log archive trace equals 1. And then we have here scope equals both. Now scope equals both is actually the default setting, but it says change it instantly in the current running instance, as well as changing it in the SP file. Now other parameters you may want to put on here is also, if you work in a rack environment, you can specify which instances you want this command to run on. So in that case, you would add to the end your SID list. So SID equals, let's say, all the instances would be in a quoted parameter at the end as well. The database must be available when this command is run, because essentially the broker will be logging into the database and issuing an alter system command. Edit database reset parameter. Well, the reset parameter command resets the specified database initialization parameter for the named database back to its default value. The equivalent is alter system reset parameter as well. So here we are editing the database self sales, and we're resetting the parameter log archive trace back to its default setting. Edit database fast sync reset parameter here. The edit fast sync reset parameter command resets the specified database initialization parameter for the named fast sync instance back to its default value. So edit fast sync Dallas, reset the parameter log file name convert back to its default value, which is null, which is not set if I'm remember correctly. Now, if you're using a zero data loss recovery appliance, you can also make use of these commands. So edit recovery appliance set parameter. So here we are editing edit recovery appliance, enterprise recovery appliance, that's the name. Set parameter log archive trace equals 1, scope equals SP file. That says only change it in the SP file, so this won't take effect until the recovery appliance has been restarted. In a similar way, we've got the reset here. So edit recovery appliance reset parameter, and resets the specified database initialization parameter for the named recovery appliance back to its default value. So edit recovery appliance, here is the name, reset parameter, and it's a DB file name convert being set back to its default value. Now the set trace level command sets the amount of tracing done by the DGMGRL client. It's a client-side setting and does not impact the tracing set for the broker within the database itself. You can set the trace level to user to limit the amount of tracing information stored, and this is actually the default setting and includes information about the fast start failover, status changes of the primary and the target standby database, and any error or warning messages that might occur as well. You can set trace level to support to increase the amount of tracing information to include lower level information that might be needed by the Oracle support services as well. So, setting trace level command examples for setting a DGMGRL and observer tracing levels. So the examples below start DGMGRL with the trace level set to the default setting of users. So you use the set trace level command is used to modify the trace level inside here to support. So we've started DGMGRL. We're saying set trace level to support. When the observer is started, you can also use the trace level clause to set the observer's trace level to user as here or to support. So start the observer, trace level is user. If you omit the trace level clause in the start observer command, the observer is started using the same trace level setting as DGMGRL has. So in this case, that would be support. So what we have here is DGMGRL has a trace level of support, while the observer has a trace level of user. So they're not set to the same level there. Set trace level command examples. Here we have setting trace level support, and the edit configuration command below is used to set the trace level of the Oracle database to user. So here we have the client set to support, but the database, so this is the broker operations inside the database, we have edit configuration set property trace level to user. So the server-side trace level is set to user, while the DGML trace level is still set to support. Another example of edit fast sync set parameter here. Now we've previously saw a reset parameter, but this is actually a set. So following examples reset the initialization parameter for a fast sync instance named Chicago, but here we're having to disable the fast sync, edit fast sync Chicago set log archive trace equals 1, and then re-enable the fast sync. Let's look at some miscellaneous changes now. The online archive location property has been renamed to archive location, and the online alternate location property has been renamed to alternate location. Both will still work for the time being. Let's look at some DataGuard broker deprecated and desupport features. As I mentioned before, you can now set instance parameters by doing the edit database set parameter command. So you no longer need to set the properties. So these properties are now deprecated. So archive log lag target, DataGuard sync latency, log archive max processes, log archive min succeed dest, log archive trace, log archive format, file name convert, standby file manager, and DB file name convert are deprecated. You don't need to set these. Well, you can still set them, but going forward, eventually they will be desupported. you need to set these by using the equivalent edit database set parameter command. The following properties related to logical standby are also deprecated. I don't think I'll need to read through those, but it's the same thing. You can now set these using initialization parameters directly. Max connection configuration property is desupported because it's desupported in the main database as well, as a parameter in archive destinations anyway. And let's end this lesson on a couple of quiz questions. Which of the following statements about replicated restore points are not true? Well, A is restore points that are created on the primary database are automatically replicated to the standby database. Yep, that's true. The restore points created on the standby database are called replicated restore points. Yeah, if they are replicated restore points, yes, they are called that. The naming convention for a replicated restore point uses the name of the restore point on the standby database suffixed with _primary. Let's just think about this. The naming convention for a replicated restore point, so this has been replicated to the standby database, uses the name of the restore point on the standby database suffixed with _primary. Well, that means we'll have endless suffixes, because we're actually saying the restore point will be suffixed with the name of the, that's not right. It actually should be the name of the restore point on the primary database, suffixed with _primary. The managed redo process, MRP, manages the creation and maintenance of the replicated restore points. Yes, it does. To determine if a restore point is automatically replicated, you can look for it inside $restore point. There's also a new column inside that view as well to say it's a replicated restore point. So the one that's not true is C. And another quiz, the observe only mode for fast start failovers enables you to test how fast start failover will work in your environment. Is this true or false? Yes, it's true. So in this lesson, you should have learnt, amongst other things, how to configure automatic redirection of DML operations, explain the functionality of replicated restore points, and demonstrate how to dynamically change the fast start failover targets.